Hi, welcome to the Calculus 2 lecture series. We are in the unit number 4, sequence and series. We are still in the lecture number 23. This is our third video about lecture number 23, the representation of the functions as the power series. If you remember the video number 1, we talked about how to manipulate the geometric series for the function 1 over 1 minus x, right? And then we can find the power series by some other function, by manipulating that function into the form similar to the 1 over 1 minus x. Then our second video, we talk about how to take the derivative and the integration of our power series. So the last video for this lecture, number 23, we're going to use the techniques, how to take the derivative and the integration of the power series, and then we're going to find the power series for that function. All right, let's take a look here. All right, so let's go to our lecture notes here. Okay, so now, in here, the key things we try to do here is so we said here we want to see the integration and differentiation. R is like the other techniques. Other techniques to help finding the power series, to help find the power series for functions here. Right, so that's why for our second video, we take a look, we discuss how to find the derivative and the integration by a power series. Okay, so now let's see here. This is the problem here. We said, let's find the power series for the natural log 1 plus x squared here. Okay, so in order to find the power series of this one, so I know this one's here, okay? So let's see here, so natural log 1 plus x squared. This one, I can rewrite it as the integration of the 2x 1 plus x squared dx, right? So if you do a simple like in here, if you do a simple u sub, so here, for example, you say u is equal to the 1 plus x squared, then du is equal to the 2x dx, right? So then the whole thing here is just be the du over u. So that's why this is natural log u, and the natural log u is natural log 1 plus x squared. So I know I can rewrite this, okay? And now in here, the next thing here, right? So we said, okay, so how do I so I need to integrate this is 2x 1 plus x squared here. Okay, so in here, let's take a look here. We know this one's here, right? So the 2x. So first things, let's take a look at 1 plus x squared. Remember, like remember, like the first video, we said we all start with this geometrics. So it's 1 minus x is equal to what? It's 1 plus x squared plus x cubed, right? This is a summation x to the nth powers, right? And from 0 to what? 0 to infinity here. Okay, so we, like in the video number 1, we said we want to manipulate, we want to match these forms, right? So this one's here, 1 plus 1 over x squared, you can treat this 1 minus negative x squared, right? So this is 1 minus the negative x squared is really is what? Is your new x, is your pink x here, correct? So then I can rewrite this one as a summation n from 0 to infinity. Then this is negative x squared to the n. Okay, so that is the negative x squared to the nth here. Okay, so if you want to rewrite it, simplify this bit, you can say n equal to 0 to the infinity. Then this is negative 1n x to the what? 2n. Now you have this 2x over 1 plus x squared. So now I just use the 2x because I know the 1 over 1 plus x squared is this series, right? So I just times it, n from 0 to infinity, negative 1 to the n, the x to n. So you can move this one in. So this is n from 0 to infinity. And so this is 2. You can leave the 2 here, right? So this is negative 1 to the n and x times x to n. So what is here? So this is the 2 summation n from 0 to infinity, negative 1n x to the what? 2n plus 1, right? Now I know the natural log 1 plus x is equal to the integration. So I'm integrating this 2x 1 plus x squared dx. That means it's similar, it's the same, like I'm integrating this ones here, right? So I'm integrating to the summation n from 0 to infinity, negative 1 to the n, the x like 2n plus 1 dx. Okay, so we move the summation signs out, n from 0 to infinity. So 2 and negative 1 and negative 1 to the nth power is all the constants, right? So I move the integration sign inside here is x to 2n plus 1 dx. Okay, so now I can find the integration. It will be some constants plus summation n from 0 to infinity. And this is a negative 1 to the nth power. It's 2. Now what is here is 2n plus 1 plus 2 ones, right? So this is x 2n plus 1 plus 1. So it's 2n plus 2. Okay, so here you can see this is the one here is 2n plus 2. Then this is 2n plus 2. Right, so the 2n plus 2, you can take the 2 out, it's n plus 1. So I know this one can be simplified to the c plus summation n from 0 to infinity, negative 1 to the n. Then this is x to 2n plus 2 to the n plus 1s, right? Because this 2 and this 2 cancel. It's n plus 1, have this c here. Okay, so now just like we figure out the, just like we figure out the C for the other ones here. So to determine that now, the next things here, I need to, determine the C's here, right? So I know the natural log. So right now, I know the natural log of 1 plus x squared is equal to the C plus summation n from 0 to infinity, negative 1 to the nth power, n plus 1, x to the 2n plus 2. So let's say let x equal to 0. So when you let the x equal to 0, you will have natural log 1, right? Is equal to the c plus, because if x equal to 0, all this term will be what? Equal to 0, right? So it's c plus 0. And what is the natural log 1? Is 0. So it's c is equal to 0. So now that's why my answer will be, so c is equal to 0, right? So I have a natural log 1 plus x squared. So this is how do I change this function to a power series here. All right, so this is how do I because so the most important part here is you need to be able to say, oh, I spot it, right? So I know, I know the natural log 1 plus x squared, I can change that to the integration of 2x to the 1 plus x squared. The reason why I want to change that is because I know the 1 plus x squared, these terms, right? So this is the term I be able to, right, change to the similar like the geometric terms here. Okay, now let's take a look at the problem number 2 here. So I want to find the power series for the f of x is equal to the 1 plus x, 1 over 1 plus x squares, right? Okay, so let's take a look. How do we do this? This one's here, I know. So this one, I know if I take the derivative of 1 over 1 plus x, right? 1 over 1 plus x, the derivative of this one will be what? Is a negative 1 times 1 plus x to the negative 2, right? So this will be equal to the negative 1 plus x to the square. Okay, so I know I'm going to find these functions, right? So f of x is equal to 1 over 1 plus x to the square. So this one will be just say it's a negative, right? So it's a negative. I can find the derivative of this 1 over 1 plus x. All right. So we use the same things like we did before. So this is our golden geometric things, right? We say 1 minus x equal to 1 plus x squared plus x cubed, da, da, da. This is a summation n from 0 to infinity to the x to the nth power, right? So now I have these numbers here. I have this 1 plus x, right? So this 1 plus x. So I can rewrite this is the negative, the derivative of what? 1 minus x here. So this negative x will become my new x here. Okay, so let's try to write it. So the here, so I'm trying to take the negative, the derivative of this function. So how do I write this function? It will be summation n from 0 to infinity, because it's negative x is the x, right? So this is negative x to the what? To the nth powers, right? So this will be the to the nth powers here. Okay, so now, all right, so I can put a negative sign here. Then I'm going to take the derivative. I can move this derivative to the inside and take the derivative. Okay, so how do I take the derivatives here, right? So these ones here, okay, so this one we can rewrite this one. This is a summation n from 0 to infinity, negative 1 to the n, the xn, right? So now the negative 1 to the n stay the same. X to the nth power by the powers rule is n to the xn minus 1, right? The only thing we need to be a little bit careful is what? Is it used to start with n equal to 0, and because I drop out n, so I need to start n equal to 1 to infinities, right? Okay, so now I can put this negative sign in here. So that will be summation n from 1 to infinity. So negative times negative to the nth power is negative the n plus 1's power times n times x to the n minus 1 here. All right. So that is what the, so I know my 1 over. Okay, so now my final answers here. So I know the 1 over 1 plus x to the square. What is my power series for this one? Is n is 1 to infinity, and this is negative 1 to the n plus 1, and the n to the x to the what? N minus 1, right? So this problem, just like the previous problem. So what do you need to recognize here? You need to recognize, you know, in order to get this 1 over 1 plus x to the square, you need to recognize that this function is the derivative of 1 over 1 plus x by a negative sign. And then the next things here is then you need to kind of, recognize this one is just be a special case of the geometric function we did before, right? So this is like we said, this is the golden geometric functions and geometric series. We find these functions here. Then we manipulate that. Then that's how do we find the power series. Okay, that's it. So we have the two examples. One is how do you use the integration? Of course, you need to recognize how did you get this function by integrate something. Then the function you integrate, you will be able to manipulate, try to what? You want to manipulate, so you'll be able to match, use these rules we have, right? So the same as the problem number 2, you need to recognize I can find the derivative of that. Then also, whatever you find the derivatives, right, you'll be able to manipulate by using this geometric series, right, to manipulate the function. All right, that's it. And so then let's complete these lectures here, how to represent the functions to the power series. All right. Okay, bye. We'll talk to you in the next, next lectures here. All right, bye-bye. Have a good day.